Okay, folks, this is a short lesson on the trapezoidal rule or the trapezoid sum. This lesson is found in that 8.6 lesson now. That's a little bit further in the book, so that explains why we didn't see it before in our textbook. Now, as you know, we got to go to our little Bible, the course description, and topic 6.2, if you notice this, it talks about approximating areas, Riemann sums, approximate a definite integral, using geometric methods. Defined intervals can be approximated with a left, right, a midpoint, and there you go, trapezoidal sum. Now, the thing to remember about this is that the trapezoidal rule or sum has to do with trapezoids, but the rule, all of the heights of the rectangles or the trapezoids are the same, or the width, if you would, the delta x part. You'll see in a minute what I'm talking about. So I'm going to go through a pretty quick explanation of this lesson, just in case you feel like you need it. Okay, so this lesson's about the trapezoid and the Simpsons. We don't use Simpsons, okay? So that takes care of that. Let's see, I don't know how to use my mouse or to use the little thing. Let me use my little mouse here. So the author is saying there's some functions that you really can't find the antiderivative to, but we can approximate them like we did with the left and right Riemann sum. And notice that these are all trapezoids right here. Notice that delta x is the width of these, but really it's the height of the trapezoid, if you remember how we first learned it. So what they're saying is we're going to approximate this definite integral, and of course the width of the trapezoids on the sides, if you would, okay, is going to be b minus a over n. That was the same thing we used when we did the Riemann sums. So what they're saying is if I have the ith trapezoid, remember this distance is really the height. There's base 1, base 2, okay. Here's the width, b minus a over n, and notice we have the height here and the height here, which really are the bases, right? Okay, so remember the formula was 1/2 the height times the sum of the bases. So you can see this over here, 1/2 the height times the sum of the bases. Now, when we try to break this down into a sum or a series, we know that we're going to have the first trapezoid, so that's what this is, and the last trapezoid, which is what this guy is. But if we pull out that 2 and put it over here in the denominator, then notice what happens. We have 2 of these f of x sub 1's. That's because that was the right side of that trapezoid and the left side of the next one. That makes sense? So what it is we have a pair all the way through here. And the exception would be the first one and the last one. So that's why that 2 is right there. And then they go through a little calculus Riemann sum magic here, and they say, hey, we got a theorem. So here's the theorem. This is the most important thing you got to get from our time together. And that is, if we are asked to use the trapezoidal rule, okay, we could approximate that definite integral by remembering the rule, b minus a over 2n times, okay, it's the y values, the one way over on the left, the one way over on the right, and don't forget to include twice all the other guys in the middle, okay? So hopefully that makes sense. And they're giving you a reminder here. Remember, it's 1, 2, 2, 2, 2, 2, and then 1 at the end. All right, here's their example 1. We have the definite integral, or find the area of the function y equals sine of x from 0 to pi. No problem. You know, we can do that using our methods. Now, compare n equals 4 and n equals 8. So here's his picture of n equals 4. There are 4 trapezoids, okay? You remember they're really on their sides, okay? So I'm going to use the rule. The rule is b minus a, so that's pi minus 0 over 2n, and n is 4. So that's where that 8 came from. And here's f of all the way over on the left. That's this guy. Here's f of all the way on the right. That's that guy. And how many guys are in the middle? 3. 1, 2, 3. Don't forget the 2 right there. Once you get to that part, it's pretty easy to figure out the rest of it. So we simplify decimal 3 places. Notice we could do 8, okay? 8 trapezoids, so 1.94, 1.974, okay? And you may remember that the area was 2. Let me try to move this up so we could see it. Okay, it's not going to let me move it up. Let me move my little guy down. Okay. Now, they give you a couple pointers here. I really like to use the technology over here, but I want to point out something here. If we're talking about the trapezoid rule, all of the delta x's are the same. But if it talks about a trapezoid sum, which the AP likes to do, you're going to have to do your individual trapezoids. Please keep that in mind. Okay, I told you I was going to go through that pretty quickly. Trapezoid rule. Let's do a couple problems. Okay, here's the assignment. Let's just, can we do this? Let's go down to, maybe not the last one, but let's do 15, okay? Let's do that now. Okay, want to try this one. It's a little radical, I could say. Okay, let's look at the directions. Approximate definite integral using the trapezoidal rule. Compare these results with the approximation using your graphing calculator. Okay. All right, so let's see. Okay, we got a line going this way, line going that way. 0 to 2. Okay, 0 to 2. Let's pick another color here. I feel like the Khan Academy guy. Here's 0, here's 1, and here's 2. Okay, well, we got to do 4, right? 4. So let's see, here's 2. So we'll put one here, put one here. Okay, so that's what, 0.5? And that's 1.5. Okay, now let's find the values here. Well, we know at 0, that would be the square root of 1, which is 1. Okay, at 1, that's going to be the square root of 2, which is 1.14. No, 1.41. So that's about here. And at 2, that would be what? That would be 2 cubed is 8, plus 1 is 9. Square root of 9 is 3. 1, 2, 3. Okay. So we all agree that the function's going to look a little like this. Whoops. Okay, that's pretty messed up. Okay, all right, anyway. So then we're going to divide it into our little trapezoids. Now, we don't have to get too fancy here, okay? Here we go. Here's this guy. Well, that was real helpful. Here's this guy. Here's this guy. And here's this guy. Okay. So remember, we're trying to make these little trapezoids. Okay. So this is trapezoid 1, trapezoid 2, trapezoid 3, trapezoid 4. All right. Now, let's look at that formula. Here's the formula. So we're going to go b minus a, that's 2 over 2n. Well, let's see, n was 4, so that's 8 times something. Okay, well, let's see, f of 0. So here's my first 1, 2, 3, 4, 5. At the left one, I just say f of 0. F of 0 plus, okay, now the second one, 0.5, I'm going to have to do 2 of that. 2 of f of 0.5 plus 2 f of what? 1 plus 2 what? F of what? 1.5 plus what? 1 of this f of 2. Hopefully I'm not over explaining it, okay? We're good. Remember, it's 1, 2, 2, 2, 1. All right, all I've got to do is find out those values. Okay, so, I figured the y values here, 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 and here. I put this all in the calculator, and I got 11.6239. But remember, I got to multiply it by 2 over 8, which is 1/4, or divide it by 4, 2.90599. Now remember, these AP people like 3 decimal places, so 2.906. Okay, that's what I would do. Now they want you to use your calculator to do that, so we will, and here's what we're going to do. A little correction, I had done some mistakes with my basic math, okay? So f of 0 would be 1 plus 0, so that should be a 1. And this guy over here, 2 f of 1, f of 1 is radical 2. 1, it's radical 2. Hold on. That was f of 0.5. Then the 1 would be radical 2. Then that's that guy. Then the 1.5 would be 4.375, and the f of 2 would be 3. I'm very sorry. I redid the math, and I got 3.283. So 3.283. I have a program for you, which you can have. We'll have to figure out how to get it to you. But it's integration by trapezoids, okay? It's the same deal. Remember our, what was our function? Square root of, what was it again? 1 plus x cubed. Okay, and then we were going from 0 to 2. And how many partitions? I think it was 4. So, there's a number there as well. Okay, that should match what we did. And then we could, if we want to actually a little trouble getting out of that here. All right, we could actually graph that function. And we could actually use the tool of the calculator, which I think is very interesting. Okay, I see we somebody put another function in there. That's very interesting here. Don't ask me how that happened, okay? But anyway, we're going to graph that. Here it is right here. And then we could just use the little tool of the graphing calculator. Go down to 7, 0 to 2, and lo and behold, we have right here 3 point whatever. Okay, so 3.24. Anyway, so, that wraps that up. I hope that helped you. I wish you the very best on what? On the trapezoid rule. Now remember, rule, same partition, same width. Sum, different. We'll come across that later, I'm sure. Anyway, apologize for the mistakes and so forth. It's a little hard putting this all together, but I wanted to put it together for you so you could see that lesson done. Best wishes.